And greetings, viewers. We are doing practically everything backwards today, but first we're going to watch the sun forward. Looking at 193 angstroms, we see diffuse coronal holes in the south. 304 angstroms, we're seeing some significant filamentary activity on all four corners. Let's check out the northern area first. Major plasma jump happening there. We did see a coronal mass ejection yesterday, and we will be talking about that in our space weather video once that occurs. Here's the southern filament. And there's a re-look at the north. And here's that area in 171 angstroms. Could be a coronal mass ejection. We'll be looking at it momentarily. But first, we're going to look at some deep cosmology stuff, as we're doing it backwards. And we spend a lot of time looking at the Cygnus arm of the galaxy, which is over here, by the way. Just north of the blazar with the catchy name 3C454.3, otherwise known as the most luminous object ever imaged. We're not going to talk about the Vela pulsar. We're not going to talk about Crab either. Actually, we are going to talk about Crab. But before we do that, I'm going to talk about the Crab pulsar. Haha, yes. Now this Chandra image is combined with a Hubble image here. So what you're seeing there is the blue portion is the Chandra X-ray image, and the red portion is the Hubble visible image. And just making note of the relativistic jet, one of which is kind of facing towards you and the other one is kind of facing away. It's angled about 45 degrees down and to the left in the photo, and you can see actually the jet is kind of curving here, and perhaps multiple filamentary jets coming off of there. The Crab pulsar. Links about the Crab pulsar from Wikipedia are featured below the video if you want to read about it. And again, Crab pulsar / Crab nebula, believed to be a, quote, neutron star / supernova remnant. It's located 2,000 parsecs estimated distance, all the way on the far side of the Milky Way galaxy over there. And you can follow the Crab pulsar's transients. The Crab pulsar is currently the strongest X-ray source in the sky. Now let's talk about another thing with a catchy name, XTEJ1550-564. Now, we do watch the transients of this, and some people watch it harder than others, with good reason, as this object used to be the strongest X-ray source in the sky until 2000, when it suddenly faded, leaving the Crab Nebula as the brightest X-ray source. Now, this particular object, J1550-564, this is considered a low-mass black hole, and there's really no modern cosmology that can explain why this thing did what it did. And basically what it did is a crazy outburst, and one of the jets appeared, one of the jets vanished. It was quite an interesting day, and actually a series of years while this object was observed. And we've got links to this article from the Chandra site below the video also, some high-end images of it. And here's one. You can see the blue relativistic jet is the one that's pointed toward the observer, and the red relativistic jet is the one that's apparently directed away from the observer. These are estimated to be, the material in these jets is estimated to be traveling at about half the speed of light. The observations indicate that the jet on the left is moving along a line tilted toward the Earth, whereas the jet on the right is tilted away from the Earth. This alignment explains why the left jet appears to have traveled farther from the black hole than the jet on the right, and why the left jet faded first. Quite an interesting scenario here. 4 years after the outburst, the jets had moved to more than 3 light years apart, with the left jet slowing down and then disappearing entirely. And here's this image. See what it looked like August 2000, March 2002, and then June of 2002. An interesting object, to say the least. And what's the point? Well, the point is that it all comes down to perspective. And we've left links to this article also from phys.org about the nature of obscured active galactic nuclei. Now, this is something that we study on the regular basis on this channel. I'm not going to really read anything out of this, as there's not really a whole lot to say, except mainstream astronomy cosmology does not understand how these objects operate. Now, one of my favorites, and of course it should be your favorite too, is Cygnus A. Now, this is the strongest radio source in the entire sky, second only to your local yellow dwarf known as the Sun. And we're viewing this in infrared, which is right there, that's the red, blue, which is X-ray, that's Chandra, and then the gold or white, that's the it's a visible light, probably from Hubble. And yeah, an interesting object, to say the least. And now this is an object which we're not looking down this thing's jets. We're actually looking almost perfectly perpendicular, as the jets appear very similar. You can see the similarity even in thermal view there, the infrared view. And you can see you can totally see the way these jets, they have to calm down before they can even begin creating anything that emits light in any sort of a normal fashion. Anyway, Cygnus A, the strongest radio source in the sky. And the point is, folks, it all comes down to perspective. If you're viewing a galaxy like a Seyfert Type 1 galaxy, the more perpendicular you are to its plane, the brighter it's going to appear. It's more likely going to appear as a Seyfert Type 2 galaxy. And it all has to do with your perspective. Are you looking down its jets? Are you looking at it edge on? Now here's M87's jets. People asked me what was on my desktop. And now here you can see, this is the famous quote, black hole, end quote, M87. And you get a perfect view of the jet as we're looking at an angle to the jet, but not directly in the jet. So if we were looking at it from this angle, it would look much brighter, and it would be much more difficult to calculate its distance. We're not going to get into redshift explanations or anything like that, but this image is another image to illustrate how important perspective is. If you view these things, if you view a galaxy like an active galactic nucleus from the edge on, you're going to get a completely different view of perhaps the same thing, as it's very difficult to judge what you're looking at when there's a synchrotron beam traveling at half the speed of light, emitting X-rays and pointing right at your face. So think of the way a flashlight in a dusty room looks compared to a flashlight that, one that's pointing at your face is going to look completely differently than a flashlight that's pointing past your head, for instance, which is what you're seeing in this case. And the jet is the brightest place, and that's what's causing the ionization pathways. By the way, if you enjoy the content, please support us on Patreon, as YouTube pays us precisely $0 for these videos. And please press like and subscribe anyway on YouTube, since it's the main source of our content hosting. Now, let's talk about the unguided spark and the guided spark. Now, why is this relevant? Well, because ionization pathways are where things form in the universe, and why things tend to form at 90-degree angles to each other. We're not going to get deep into the Hall effect, but now this Weather Channel video is about creating a plasma lightning rod using a laser, because you create an ionization pathway with the light. So let's just play a little clip of the video and not get banned for copyright infringement, since we just spent 9 minutes talking about ionization pathways. Now you're going to see a perfectly straight plasma discharge there. And this is because the laser being turned on. As you can see there, the unguided spark versus the guided spark. And what's the point, folks? The point is, these are where things form in the universe, which means Z-fields are the key to things like planetary formation, galactic formation, and the formation of clouds and so on. So I'm not going to get any more in-depth than that, but we've left the links to all of the articles here, so check those out. Please press like and subscribe on YouTube. Please share on your social media. And remember, when you're striving to understand the strangest objects in the universe, don't drink, and if you drink, stare at the strangest objects in the universe anyway. Just don't drive. And since it'll never be now again, stay tuned for another video. It won't be backwards. It might be back-asswards, but it won't be backwards. It will be forward.